In this session, we will discuss how to select boundary conditions in Fluent Meshing software and when to select these boundary conditions or what is the scope of these boundary conditions. First, we generate a geometry, which is a 3D cube in SpaceClaim software, and create name selection. Then import it into Fluent Meshing and set Add Local Sizing and generate the surface mesh. We describe the geometry as only fluid and then go to the Update Boundaries section. In this section, as you can see, the software chooses the boundary condition type from the names we used in the CAD software. For example, it selects velocity inlet for the inlet, pressure outlet for the outlet, and symmetry for sim. For the wall boundary, it selects wall. From here, we can change the boundary conditions. Velocity inlet is used at the inlet, specifies velocity magnitude and direction of incoming flow. Used when the inlet velocity is known. Pressure outlet is used at the outlet, defines static pressure at outflow, a standard outlet condition that lets flow adjust naturally. Pressure inlet is used at the inlet, applies static or total pressure at the inflow. Commonly used in compressible and external flows. Far field is used at the inlet-outlet external flow. Represents free stream conditions, velocity and pressure. Used in external aerodynamics, e.g. airfoils, vehicles. Mass flow inlet is used at the inlet. Imposes a mass flow rate instead of velocity. Useful for ducts or pipes with a measured flow rate. Mass flow outlet is used at the outlet. Fixes a mass flow rate leaving the domain. Rarely used. Suitable for special internal systems. Outflow is used at the outlet. Assumes fully developed flow at the outlet without specifying pressure. Quick option when outlet data is unknown. Symmetry is used at the domain reduction at boundary treatment. Defines a symmetry plane. Reduces domain size and computational cost without changing flow physics. Wall is used at the solid boundary. Represents solid surfaces. Can impose no slip, roughness, and thermal conditions. Internal is used at the connection. Represents surfaces inside the domain created by mesh or shared geometry. Not physical, often converted to a wall or interface. Interface is used at the connection. Connects two mesh regions or zones. Ensures smooth transfer of flow across conformal or non-conformal meshes. Overset is used at the interface. Connects overlapping or moving meshes with a background mesh. Used in sliding, rotating, or moving body simulations. Outlet vent is used at the outlet. Models a vent to the environment. It can permit both inflow and outflow based on the pressure difference. Intake fan is used at the inlet. Models inflow driven by a fan curve and used where a fan pulls fluid into the domain. Inlet vent is used at the inlet. Represents a flow vent connected to the environment where fluid can both enter and leave depending on the pressure difference. Commonly used for HVAC systems and ventilation openings. Exhaust fan is used at the outlet. Defines outflow through a fan based on a fan curve or performance data. Porous jump is used at the internal surface. Represents a thin porous layer with a pressure drop. Common in membranes and filters. Fan is used at the internal boundary. Simplified fan model adding pressure rise across a surface. Easier than full intake exhaust fan models. Radiator is used at the internal porous thermal boundary. Simulates a heat exchanger or radiator. Combines porous resistance with heat transfer effects. Multiple types is used at the mixed BC's multi-zone. Represents the combination of different boundary conditions in one model, e.g. inlets plus outlets walls based on the physical system. And finally, we click on Update Boundaries.
I hope this video is helpful for you. To benefit from Mr. CFD's services, including simulation, consultation, and training, visit our website, www.mester-cfd.com. Contact us via info@signmester-cfd.com.